The section for today is 3.7, Solving Absolute Value Inequalities. I want to start out looking at union and intersection, how they relate to absolute value. Then from there we'll get into solving the absolute values, which is basically the same as when we did absolute value equations, except for with one little change. So the first thing, Roman numeral 1, is union versus intersection. And I'm going to make a chart of sorts with that. And I'll probably draw the chart in later, but I want to start out saying, well, if we have absolute value of x, if that's either less than or equal to, so I'm maybe going to do like a kind of a dotted thing there to show it could be less than or equal to. But if you have absolute value with x in it is less than or equal to a number, then that's going to actually be an intersection type of problem. And when we have the intersection, the word for intersection, hopefully you remember that that's and. So we had and for intersection, or for union. Then this last part is I want to say that it's the inside range. And if you think back to the last section we were doing in the book, that when we had intersection, the answers typically looked something like this. So it could have been either an open circle or a closed circle, but it pretty much was always like in between two circles on our number line. So we had that middle part there was the solution. And again, the circles could be filled in if it was a less than or equal to. So now the second thing that we could have is instead of a less than, we could have absolute value with x. So it could be absolute value of 2x or absolute value of x plus 4, but something with absolute value and an x inside there. If it's a greater than, or perhaps a greater than or equal to some number, instead of intersection, we're going to have union. And the word for union was or. And if you think to section 6 in our book, that typically then when we did these union problems, on a number line our answer was going to be the outside part. So it could be an open circle, could be a closed circle, but we typically, it was going to be outside the circle is what was shaded. And maybe make this one a closed circle, and you could put a number on there if you wanted to, but our union problems usually look like that. So I'm going to say then that that's going to be the outside range. And if you want to try to make that into a chart, you could. I'll maybe draw a box around it. But that's going to be the first part. That's going to be kind of a little bit of a change in what we did before the absolute value, but tying in the last section on union and intersection with this. So I'm going to jump ahead to the steps. And the steps here are pretty much the exact same as we had before. I just want to add really one line in there. So before when we did our steps, our first step was always isolate the absolute value. So isolate the absolute value. In other words, if you have absolute value of x, then a plus 4 outside the absolute value equaled something, we always would subtract 4, because we're just trying to get the absolute value by itself on one side. And once we've isolated, once we on one side just have absolute value, then before we said we broke that absolute value into two problems. And if that doesn't sound familiar, we'll do an example here in a minute, and it'll help. The new thing is going to be this. I'm going to put it in red for dramatic emphasis, and say, and flip the sign for the negative number. Or we always said like whatever's inside that absolute value equaled the number it equaled, and then whatever's inside the absolute value equaled the negative of that number. Now here we'll have like a less than instead of an equals, and we'll have to flip the one that goes with a negative number. Again, that'll make more sense soon. And then step 3 was solve both to get our answer. Alright, so if you need a review on it, you could kick back to an earlier lesson where we were looking at solving absolute value equations. But for now, we're just going to jump ahead and do one with one of these inequalities. So I'm going to say Roman numeral 3 then is examples. And my plan is to do a couple of them. So my first one, example 1, I'm going to say we have absolute value of 4x minus 1, and then plus 2 is greater than or equal to 8. So our first step is to go through and solve or isolate the variable. Rather, isolate the absolute value. So we start by subtracting 2 from both sides. Then we have an absolute value of 4x minus 1 is greater than or equal to a 6. Now here was the part where we always broke it up into the two things. So we're on that step number 2 over here, break it into two problems. But the new part is we need to flip the sign for the negative one. So before we would say we have, alright, 4x minus 1 equal, but here we have a greater than or equal to 6. So we just copy that down the same as before. And now we have a 4x minus 1. This side is going to be the one where we change the sign, so it would be a negative 6. But when we kind of change the negative, or change the sign, it's kind of like multiply by a negative number. So we have to flip the sign. Now we could go through and solve the problem just like we did before. We add 1 to both sides. You could do each one individually. You could do them all at once. So 4x is greater than or equal to 7. Over on the right side I have a 4x is less than or equal to, now we have a negative 5. And last but not least, we divide by 4. We'll do that to both of those. And we're left with x is greater than or equal to, and you could leave it as 7 over 4, or I'm going to say it's 1.75. And on the other, we have a x is less than or equal to negative 1.25. And you could leave it as a fraction. So that's kind of the mechanics of it. But now if we flip back to our original problem, we said when you have a greater than or equal to, it's a union. So we're going to have this outside range. So if we kick over here then, we could go back even where we broke it up if we wanted to, and put in our, okay, because our original problem was this greater than or equal to, it becomes a union one, so we could be putting or in each of those. Which now for our final answer, we could give ourselves a number line to work with. And for this one over here, I'm going to do that in the green. So we have x is greater than 1.75, so I'll put my 1.75 there. X is greater than or equal to, so it'll be a filled in circle. And x is greater than that, so we shade to the right. Then for that next one over here, we have a negative 1.25, so negative 1.25. And it's less than or equal to that, so the or equal means we do our filled in circle, and we shade to the left. So the final answer on a number line would be this thing here, and it includes both the orange portion and the green portion. So that's one example where we did the union. Now if we were to do a less than problem, so here I have my example 2, so example 2, I'm going to do a little bit simpler, so it'll take us a little bit less time to solve. The absolute value of x plus 4 is less than 7. Now with this one, it's less than, so it's going to be an intersection problem. And our variable is already isolated, so we start right away with a step where we break it apart. So I'm going to say, alright, my x plus 4, that could be less than 7. That's the one that we kept the same. It's a positive 7. Then our other option is going to be x plus 4, but now we need to flip the sign to a greater than because we're saying it's a negative 7. And because if you go back to the chart we did at the very beginning, we have one of these less than signs. Because of that, now it's going to be an and in between those. So we have and. Now if I were to go through and solve, I'm going to subtract 4 from both sides of each of these inequalities. And I get a x is less than 3 and x is greater than a negative 11. So if we want to graph our solution, we give ourselves a number line. And I have on the one side, maybe we'll pick orange for this. We'll do this one here. The x is less than 3. So I have my 3, and less than means we use an open circle, and we need to shade everything to the left of that. Then over here on my other side, I have a negative 11, so that'll be on this side of my 3. It's greater than, so that's an open circle. We need to shade everything to the right. But because we have this and, because we have the and there, we know that it needs to be intersection. So we're only going to shade the stuff that's shaded twice. So here in the middle I have my orange and my green. So that there is going to be part of the answer. And when I have my negative 11 there, it's only one time. Only the orange goes through there. So it's still going to be an open circle on both sides. Which then, maybe just to clean it up a little bit, let me erase these just so it's a little bit more clear what we're looking at. And then say, so that there in red would be the solution to our original problem. So that's really kind of the gist of the notes. The only last thing I want to say is that there is one possible shortcut that we could use. And I'll throw that out there. This is the kind of thing where if you get it, it's going to be nice. If you don't worry about it. You can go back and just solve it the way we were doing it. So Roman numeral 4 is going to be a possible shortcut. And this is a little bit hard for me to explain, so we'll see how it goes. But if we have absolute value of x is less than a, we know that's going to be an intersection. If you go back to the absolute value, the definition of it back a couple chapters ago was that the absolute value of a number is going to be its distance from 0. And so when we go through and actually try graphing this thing, if we put a 0 on there, what we're trying to say is this absolute value of x, it's going to be a away from 0. So you could say, well, if I have a here to the right, and I have an a here to the left, that's going to be pretty much where my answer is. So over here I'm going to have a negative a, because it's a away from 0. Over here I have a positive a, because it's a away from 0. Because I have this less than sign, I know two things. One, it's going to be open circles, but it's intersection. So the answer to that is going to be this portion here. So that's with the union. If I were to go down and say, all right, I'll do that same sort of thing again, but now I have absolute value of x is greater than a. Actually, maybe I'll do greater than or equal to, so we'll have the closed circles this time. And you get that same sort of definition that, well, we're starting now at 0. 0 is going to be in the middle. And over here I'm going to be a to the right, because this distance here would be a. And then I'd have that same distance here. So on the left now I have my negative a. And it's going to be a filled in circle on both of those, but because it's greater than, it's going to be the outside portion. So you can kind of use this somewhat as a little bit of a shortcut, especially if you see this last part. That what we really are looking at is, we could for both of those maybe, do you agree I could put like a little minus 0 in there? It's not really working. But absolute value of x minus 0 and absolute value of x minus 0. That, if I change that green absolute value and the orange absolute value to this thing here in red, it doesn't change it any. And that's where 0 is going to be that midpoint. And the reason I bring it up is, now let's say we had something like absolute value of x minus 3. What we're going to find is that 3 is going to be the middle number, where our previous two were always centered around the origin. What we could say now here, it'll always be x minus the value. So even though it's a minus 3, it's really looking at, well, instead of being centered at 0, it's going to be centered at 3. And say I had, is that problem there would be is less than or equal to 4. Well, 4 now is my distance away. So if I go 4 to the right, 3 plus 4 is going to give me a 7. If I go 4 to the left from 3, that's going to give me a negative 1. It's less than or equal to, so that means we have a filled-in circle on both of those endpoints, the negative 1 and the 7. And because it's less than, we know it's the section in between. So if you kind of see that pattern, that x minus a value, or if we had a x maybe a plus 2, what that one would be is that'd be that the center is going to be at a negative 2, because you have x minus a negative 2. Sorry about the cuckoo clock. And then you could figure out your distance away from that negative 2. But that's something that could come in handy if you understand how it works. So that's all I have for this section.